Dear listeners, welcome to the fourth episode of our podcast series Big Data, Big Challenges, and Big Real Success. My name is Anna Przybył, and I will be your host. Speaking from a business perspective, I will ask my guests, experts in the data and AI field, questions as they share their insights, real world challenges, and professional experiences. I hope this will provide valuable knowledge from different perspectives. These podcasts are made possible thanks to the boutique company Sofixit, which specializes in data and AI related projects, services, and solutions such as data lakes and data lakehouses. Sofixit is also well known for their nonprofit initiatives, which have a positive impact on the entire industry, so it's worth following their LinkedIn channel. Today, we will be talking about data integration, processes, possibilities, and challenges. And our special guest today, is Filip Dzięcioł. Hello, Filip. How are you?
Hello. Thanks for hosting this event and inviting me. I'm very good. It's a good weather, so we can talk a bit about the data integration. Hopefully not too technical, maybe not too business wise, but we'll see. We'll see.
Okay, great to hear it. And have you here with us. And well, could you tell us a few words about yourself and your place in the data world?
Yep, sure. So, where to start? My day-to-day work is being a data engineer and data architect, mostly currently in a healthcare company, but I was also working in retail, in supply chain, in telecommunication, and e-commerce. So, a few fields within the data world as leader, architect, or data engineer, and basically anything that is related to data. And few more initiatives from my side is leading an AI company. So I have my own together with my friend a startup regarding AI, and so we are implementing some grants, some academia research. I'm also teaching on Polish-Japanese Academia of Information Technology in Warsaw, and from the data side, I'm also part of a Dama Poland chapter, which is a set of enthusiasts on data, managers, people that like data basically. For us, it is very hot topic, so it's always good to talk to these people.
Well, amazing experience. I think that this will be great talking today. So, Philip, to start with, so we are going to talk about the data integration. Yeah, well, probably most of us know what is data. Probably most of us know what is integration. But what actually is data integration? Well, if you could sum this up in a few words.
Yeah, so data integration is actually a very basic of the data engineering field. So usually we refer to this as an ETL or ELT. So this is extract, transform, and load. And these are three concepts that are always merged together. And this is basically a data integration. And the goal of the data integration is to basically connect many disparate systems and their data. So it's like merging different data sets, different systems, maybe not always data as an integration, but overall the information that is shared between systems. And this basically helps a lot of downstream systems to use the data. So this is like a core enabler, let's say, for the data world.
And is it like that you merge all the systems or you just choose some systems to merge the data from?
It depends on the use case basically, because we usually need to understand what does the business do, what do they need basically, and we need to think what are the SLAs on their side, what do they need, and we need to be able to connect these systems in a way they can use it basically. So this is the most important part probably.
What about the goal? Is the goal the main like aim when you think about these systems and the data you want to put or just merge together or want the data to collaborate together? What is this?
Yeah, the goal is to make sure the data, the value that is carried within the data can be used. and that can be shared to other consumers, right? So we are between data producers, so many systems that produce the data. We are somewhere in between before the data can be consumed. So the goal is to share this data to the people that can actually get value out of it. So in the data integration, we do not particularly look at the data, but we look at the overall picture of the data. How does it come and where it needs to go?
So we don't think here about the values of the data yet, or do we think about the value here? No, not yet.
Yeah, exactly. So we are not interested if this row has country Canada, for example. We know that this data set has attribute country, and of course we need to take care of that the country is properly referenced as an actual country, not the number, for example. But we do not care about the specific values, right? We just need to make sure that this value is in a range or something, or that the value is not empty, for example, or it is part of some superset or something like that.
Thank you for explaining this for me. Okay, and why is this data integration so important?
Well, as I mentioned, this is a core enabler for any data initiative. So there is on the Dama book this like 800 pages of the data management body of knowledge, and there is a concept called icons pyramid. And icons pyramid is a pyramid which states 4 stages of the data project, and the data integration is in phase 1. So this is a core, one of the first actions that we need to take to be able to build any data value out of it. So this is the core concept, and this allows to firstly collaborate, and secondly to get a value out of data out of many systems. Without it, every business person or analyst would need to go into one of 100 or 200 systems to get some information and then connect it to themselves. Instead, we have some more or less centralized place where they can just go there, they can search for data, they can search in data, and they can get some results that can be then shared to shareholders, to stakeholders, to make right decisions. So this is like a data-driven company, data-driven decision making.
Is it usually just like one place, yeah, in the company where the data is stored, or is it like that for example you have two sources, or because as far as I know, yeah, when we are talking about AI driven company, then it's like one source. But how does it look like in a real world?
Well, we usually try to get data in the one place, but not the data itself, but the view on the data. Many data sets are having many compliance, many regulations to be set on them, and this data is attributed to different domains, to different teams. So they need to be in charge of this data, right? So they cannot just give this data just like that. That's why we are usually putting some view level on this. So this like usually this is some kind of data catalog, for example, where the business person can, or even technical person that needs to take a look at the data, can go into a single place, take a look at the single, from their perspective, centralized place. But this centralized place can reference to many distributed systems. So the data lies somewhere in the company, but the view on the data is unified. Very often, currently, there is a large movement into the data fabric. So this is like more of a virtualization for the data, where we can simply take a look at what's available, maybe get an access to this one, request for the access based on some business context, and the data can be then moved from system to system, but not to this centralized place, right? So we want to view centrally, but operate on data locally.
That's an interesting idea, yes. So you just have the data that is needed and necessary for some for your reasons, not all the data. Yeah.
Mhm.
It's a
Yes.
great concept. Just to coming back to what you've said, is it called data fabric? This is this idea, because you've just mentioned it, yeah, this data fabric, and it makes me curious what it is.
Yeah, so basically, data fabric is a central place where usually technical people can get access to some data. So they are actually moving the data by themselves. Regarding data catalog moves only metadata, but enables the request to real data. So it's like these two concepts is like data fabric from the technical side and the data catalog from the non-technical side, for example. So this is of course there is no clear transition between all these technologies, right? Because we can even get a single database that does all of it basically, and hides this complexity of distributed systems. But overall we are distinguishing these systems because they are deployed differently. They are having different teams assigned to work on these, etc., etc. So this is not easy. This is very very complex. Maybe on overall data architecture side, but all of this is enabled through the data integration. So at the bottom layer out of it, there is a data integration that has to be set. So we can build data fabric, we can build data catalogs, we can build metadata, and basically create dashboards, create visualizations for the business.
All right. So it seems that it's because it's so basic, it's really important so probably there are also many challenges when working on data integration. Could you elaborate a little bit about this topic?
Yeah. There are many challenges, definitely. From my day-to-day work, when I'm working mostly on the engineering side right now, we need to handle things like data is changed, not only in case of structure, but the data itself is changed. And on the data integration side, we shouldn't care, but we need to care about this. So, for example, we need to get some tests, for example, that some attribute is in a set of 100 values. Otherwise, it should fail. It shouldn't be integrated because it will be basically contaminate all the downstream systems. So we are like the gate for the data quality, and these changes can go just like that any time, any day. If we are, for example, integrating data daily, then every day after the integration is completed, for example, after 2 hours of processing, if this is completed, we can get a green, right? Everything is all right. But if we look at it, there are a lot of issues. This is very important, and it is very, very hard to catch all of it because every data producer has its own pros and cons. They have their own data formats, they have their own operating life cycle. It is very hard to align to all the producers, and that's why there are a few concepts that we need to employ, like canonical model or data contract. But maybe before that, our main issue is that these systems produce different data. This data may mean different things, and this is why we need to be able to not only integrate it, but also we cannot pass data that is a low quality, because it's very hard to reproduce, to cure basically. So these are the challenges that we are spending basically full time on, just monitoring this data. So this is the concept of data ops basically. And this data ops is making sure that the data is monitored, it is a high quality, it is automated. Of course, in the data world we have a lot of automation, and we need to properly define what does the quality mean, because this is again different for producers, different for consumers, different for technical business people. It's very hard to unify, and there is a lot of consulting around data integration. So it's not like we are writing some Python scripts. We need to spend a lot of time to describe what does the data mean, what should it mean, what is expected to be meant, and it's like it's a never-ending story basically.
Fascinating, I would say. Well, and so do you spend a lot of time with these groups of people? I mean, do you talk to them? Do you have some, I don't know, list of or checklist? How do you work to get to know what's the quality for these groups? Because you have to get to know somehow, what it is, and it sounds interesting to see how you do it.
Yes, there are many stakeholders to the data, and there is a huge issue that is still an issue, but maybe not even the issue. This is some characteristics of the data world, where we have centralized data team that is managing all the data in the company. So this is like this actual centralization, not the view, but also everything else, right? And this is a problem because there are like hundreds of stakeholders, and each of them may have different requirements to data. So if we are working on a single system, we need to merge all of these requirements into a single set, and these requirements are very often contradicting. So this is a large issue, and that is why we have concepts like data mesh or decentralization or splitting into different systems, because we need to separate the viewpoint of the stakeholder and prepare a system so it matches this particular person or set of people that are responsible for the data. There's one actually fun thing that there are a lot of discussions on the who does the data belong to, business or IT, and there is like, well, IT says that this is business and business says it is IT, right? And
Right.
based on what I've seen in many conferences, it's like business should own the data. So they are responsible for the quality, for how it operates, or and the requirements, of course. And on the technical side, we should basically just fill these requirements, right? So we need to in a DevOps or agile ways, we need to employ best practices so we can catch up with business. They shouldn't wait for technical people, right? And that is why also they should be the owners of the data. And this is also why we have so many consultations or discussions about this, because if we are going to merge all of these requirements into a single system or single architecture, this will not gonna work, definitely. And that is why we need to firstly be able to split it properly, and then we need to define the stakeholders and discuss with them on their requirements, and of course then eventually prepare the system for them.
And here I have got one question, additional one, because just a few moments ago we were talking about data catalog. So it means that when you just splitting and then merging, yeah, do you create different data catalogs for different stakeholders?
No, data catalog, it should be basically a centralized place for whole company. There is a very, very good book, Enterprise Data Catalog, by Olsen Bogno, I think. I'm not sure. Sorry, Ole, if we are listening to this one. But there is a really good book on the data catalogs, and he was advocating the approach of enterprise data catalog, where the data catalog is like Google search for whole company. So not only data sets, it's like including SharePoint, including documentation, including everything. So usually we would like to have a single place for everyone to view things, but regarding the development, the updates, etc., it should be decentralized for within our domains. So I would also support this statement. I think we should have single place to search for data, not particularly in data.
All right. So thank you. Thank you for that. Now I think it's more understandable for me, because I thought, that it's something done for each stakeholder, or a group of people. For example, for sales, you've got different, yeah, and for marketing, different one, yeah. But as you've said, now I can understand that this is the data catalog is just the data connected to the one company, yeah, and then you can use it from different places, but you have the access to all the data.
Yeah, there's one important thing, because
Mhm.
we cannot be in a place where everyone has access to everything, right? Because this is completely insecure. To make sure that
Exaggerated a little bit.
yes,
This
exactly.
statement, yeah,
So
I understand.
we need to make sure that if anyone is requesting for some access to the data, they need to have some business context, they need to have proper role in the organization so they can actually do it. If someone is, for example, in finance domain, they should be able to ask only for finance data, for example, right? This is of course a matter of strategy, of policies, but we need to make sure that there is some, usually it's role-based access control, where where the roles are specified for a group of people and they can access, or they can even view some parts of data, right? So we don't want, for example, for engineers to view the company yearly financial data or something like that.
Okay, so it's another struggle, yeah, another challenge you have to face. Is it just, I don't know, quite difficult, to do it, and how to do it when the company is growing up, because I think that it seems to be really, really challenging, yeah, when it comes to GDPR and other regulations. And of course, yeah, exactly, the access to the data that shouldn't be accessed, yeah, by some people, some group of people.
Yeah,
So
yeah, definitely. But definitely the security aspect is very, very hard to implement. And there is, again, separate teams that are working on security architecture. So defining this hierarchy of roles, defining on what your role should have access to what, and everything that is underneath, right? So data security at rest in transit is like another world.
Okay, I see. And okay, before you talked a little bit about this concept of this pyramid, I mean,
Mhm.
and that on the basis of that there is actually data integration. Could you tell me a little bit more about methodologies for data integration? Probably I mean, you have to, if it's so important, yeah, you have some, you because you've mentioned it before, yeah, that there is some way to do it in a right way. You can, yeah, decide on this attitude or another. So could you tell us a little bit about which way we can follow if we decide on working with data and on integration of all these sources?
Yeah, I think the most basic part is the ETL versus ELT. So this is a standard choice we need to make at the beginning of the project, usually at the beginning, but of course it can change with time. So we need to validate which approach is better for us. So extract data from the producers, then transform it to some common format, and then load to the desired database. Or we can do it slightly differently. So we are doing extraction, then we are loading it as is into the database, and then we are processing it in within the database to the desired format. And this ELT, the second approach, is currently a standard. This is because the database systems went much more deeper into the optimization of these data flows, so they are much better optimized to process such data, especially that this data is like very often terabytes of data daily, and they basically support this concept of batch loading and real-time loading. So we need to make sure that we have scalable system, right? So we need to take care of the infrastructure, that it can, usually we need to scale this out, so we are just putting more machines that can parallelize this. For the more technical people, probably MapReduce concept can be kind of well known. So we are doing data splits based on some key. We are processing in parallel at the same time, and then mapping or like reducing this to the final data set. So in common databases like Redis, Snowflake, Databricks, we can have this just out of the box. So this is happening underneath. We just need to make sure that we will not pay like $1 million that daily for this one. And by the way, in the integration, the worst part probably is the cost versus time, because we can process everything in a few seconds. We will just pay for it like few millions per second.
Wow.
Maybe we need to make sure we are not going to do that. But yeah, basically the next part that we need to take care of is how are we going to integrate the data. Usually we are dealing with many data sets. For example, we can have customer and sales, for example, or inventory, and these are having completely different characteristics, because for example we have a set of customers which are, let's say, 300,000 customers, and this is called a master data. So this is the data that is common across whole organization, and this master data usually has to be simply refreshed fully from some centralized system. So we can do it in a way that we are merging new records, we are appending only new records, we can update existing or insert, or we can simply remove everything and then insert the fresh version. And for master data or reference data, this is usually the best case, because like full reload is the easiest one, the easiest approach, because we are just removing everything, placing again, and it's over. It's very efficient if the data set is small. On the other hand, we may have data sets like inventory. So let's say in the retail, each shop will have, or each location or SKU will have few millions of records to be updated or inserted daily. And if we have few hundred of this, we are ending up with like billion of records daily, for example. And this cannot be simply reinserted, because it will so much time and so much resources. We will not do it definitely efficiently. So we need to choose how we are going to integrate it. If this data set is only new records, then we can simply append it. It is very efficient. It's very only, the append only is very, very rare case, I must say. Usually we need to validate which records were changed and which are new, which one will delete it once. So this is why we need to like check usually row by row or day by date or month by month the data, and we need to merge this into currently existing data set because it will be much more efficient. So we need to choose if this is a full load, so this like reloading completely, or we have delta load. So delta is a difference, right? In math, the delta is usually the difference. So we are just processing the changes on the data, and there are a few parts that it can take care of it, but I think it's much more technical. But overall,
Can I just stop you for a second here? Because this concept of the data load, how often can we do it? Do we have to do it in real time? No, not really. Yeah, we just probably have to do it like weekly, monthly. Probably depends.
this is excellent question because this is another part that was like the final part that I wanted to go through. The very good one.
Thanks.
This is called orchestration, basically. So, we need to validate with business what do they mean by real time. First of all, because real time for one person means every second, for another person means 1 millisecond, and for another one means once, for example, on Monday's morning, for example, right? So this is this is crucial because this impacts how the system is overall architected. So this is probably first decision point on the data integration part. So we need to define what is the real time in their world, right? And then we need to validate what approaches can match this. So of course we can load data every 1 millisecond. If this is like row by row, this is like a almost real time, right? We call it a near real time data integration, and usually then we are processing like row by row as it goes. And for example, systems like Apache Kafka can process like millions of rows per second, but sometimes the systems are so complex that we can process, let's say, 100 rows per second, because they are enriched, there are many tests to go through, there are many systems to reference, to master data, to some, for example, country codes as a reference data. So it really depends on the complexity, and at some point we need to first validate what do they need, and the second one, how much it will cost, simply to put it through. So again, we can integrate every second, we can integrate once a day, and I think once a day is the most common. We usually have night loads. For example, at 10 p.m. we are cutting off the accesses to the system, and for next 6 hours we are processing data, for example. Sometimes the data is much larger, so we can do it once a week, for example, during the weekend. We can sometimes do it once a month for the load that is going for 7 days, for example. It really depends on the data and the cost, but usually we need to just choose if the business is okay with the cost associated to the real time, because real time is much worse to monitor, much worse to process, to prepare, and it costs much more, really. So that's why the batch processing, which is gathering rows for some time and then processing everything at one time, is much more efficient usually, and this ELT approach supports it very well, and it just costs much less because we are spinning the infrastructure to the high levels, we are processing it like for 1 hour, and we are shutting it down. In real-time system, we need to have systems operating 24/7. So this is, again, it's very hard to optimize. So yeah, these are probably, I'm not sure if I answered properly, but yeah, it's a long journey definitely that we are going on daily basis on the data integration side.
Yeah, it sounds like that. Yeah. And here comes actually the question of data engineers working at night or at the weekends. Is it like that, when you have to, for example, stop and work for 6 hours at night, that you are there, and you are on the duty to do it, or can you prepare it beforehand?
Yeah, we as I said previously, we need to automate as much as possible. So we need to automate, whole integration has to be automated. There is no other way. I mean, we are not putting like zips over SFTP, which is sometimes happening, but again, using automated way, not manually. But we definitely need to have some monitoring, and if anything goes wrong, we usually need to dive into the system, and we need to very often manually reprocess something, or maybe retrigger some failed job, or sometimes we need to even adjust records. For example, from old records were not deleted and the system is overloaded, or new records were not inserted properly, and out of it we need to do some retrospective on what went wrong, etc. So I think it is overall rare case where we need to stand at 6 a.m. to review what's going on. But if the customer is really in, let's say, hypercare, or they and our technical leaders agreed to that we need to monitor it at 6 a.m., then well, yeah, we need to review it. It's rare, I think, because usually we are just, as a data engineers, we are starting the day usually on checking what if pipelines went through properly. So this is the usual start of the day before daily, and on the daily we can discuss it, and we can of course then plan if anything went wrong, how to mitigate it, how to develop a system so it is corrected. On the leadership side, I would not agree that my team has to stand up at night to monitor something, because it should be automated, right? We can automate it during our standard core working hours, and if anything went wrong, we shouldn't agree that we need to correct it in 15 minutes, because sometimes analysis takes 2 days, for example, of what went wrong. Or like firstly we need to cure it manually, and then we need to develop for 2 weeks to avoid such situation in the future. Of course, it depends on the customer. So again, a lot of consulting, that do they really want to have this data every 15 minutes? I mean, if they are again waking up at the same time as we do. So this is again a large discussion, but yeah, so there are some cases where we actually need to stand up in let's say Saturday at 8 a.m. to review if everything is all right. If everything is all right, where we are closing the laptop, we are going to enjoy the morning. Otherwise, we need to spend like 1 hour or two to curate it, and then we are closing. On the Monday, we are doing some retrospective on that. But data environment is very volatile. It is very hard to even find the issues. If code fails, we can see it usually. It is relatively easier. It is easier than in data, but data is very dynamic. We are not only taking care of the code, but also the data that this code prepares, processes, and the code is usually more or less generic. So it will not look through the data directly. So sometimes we need to have again separate code that checks the data or monitoring if everything's all right. So this is a very interesting field, definitely, but also challenging, because we are never sure what's going on. It's like you must be able to sleep properly, because you are not sure if you are waking up at 9 or 10 a.m. and you are starting your work day, and well, everything is red. You never know, basically never know. Even if you are the best in the world, you never know.
It's a surprise in the morning.
You don't need coffee sometimes.
Yeah. Filip, thank you for just explaining me that data engineers don't have to work at nights, that they have just some tools to
Usually.
for them. Yeah, usually our code, and they actually iterate on some challenges if they happen, so that they avoid them in the future. But here actually comes the idea of canonical model, I think, yes. And because I've heard about it, but I don't know a lot about it yet. I know that it can be also connected to automation and working with data. What is this canonical model? Can you explain to our listeners? Because I know that it can be quite an important notion.
Yes, so canonical model is a concept where whole company or set, or it's a subset of the company, has a similar data characteristics set at the top level, and on the bottom we just implement or adhere to these concepts. So if we decide that, for example, we have a field customer, this customer has to be, for example, a number. And every system in the company has to make sure that this is actually number. And thanks to that, we can define set of entities or set of fields that are processed in the same way. They can reference the same master or reference data. They can have similar data quality checks and monitoring. So if we define all of these entities that are used in particular in set of company, or maybe in superset of the companies, we can have a much simpler data integration processes. So we can prepare our systems from the start, from the beginning, to integrate this kind of data and these characteristics of the data. And this is really important because it also breaks down the silo on the teams, because they start to talk using the same language, using the same phrases. So this is not only the technical improvement, but also cultural. So this is commonly used in the data mesh world, or overall in the enterprise data architectures, together with things like data contracts, automation, monitoring, central monitoring of all the data. This really helps, and I think this is one of the most important concepts that we can start implementing, this canonical model. But from my experience, this can be also a huge obstacle. It has to be done really carefully and really well, otherwise teams will be just fighting against this. For example, I had an experience in place where we had this canonical data model developed already and in production, and the issue was that this canonical model was not matching customers' requirements or data. So we had to use different fields for different data, even if it had different meaning, because we couldn't just get a new field, right, developed. And sometimes we had to just use custom fields. This was very hard to fight against, and we knew this is incorrect, but we couldn't overcome this. So this has to be done very carefully, and it has to be done using some enablement teams that can support the deployments, and of course data engineers and architects have to have a lot of knowledge within this space, because sometimes also customer cannot simply identify what is needed. This is again consulting part that is very, very common.
And well, when it comes, because this idea is so crucial, so are there any good practices that we should follow when introducing this system, this way of thinking in our company?
I'm not sure if set of best practices. I think this is mostly on setting up right entities and right format for the data. So, for example, we can set up, let's say, 100 core entities in the company that are used within the company, and for example, finance are using 20 of them, retail is using 50 of them, etc. But basically, they can pick this up, and this is usually, it can be JSON, YAML file, or any human readable file. It should have some readable metadata, so people can actually understand this. And there are two main things to the canonical data model. We need to be able to define automated checks that are distributed across all the projects. So, for example, as I said in this customer example, where we are defining what kind of value. So, for example, this has to be a number, this has to be a string, this has to be, for example, a reference to some other system. So we can also reference some core or master data systems, and we need to be able to monitor and automate checks the same way that is done everywhere. So this entity is processed in the same way everywhere, and this supports the data integration, this supports discussion, this supports also transition between projects and even within the same project. So we can define this current, as in TOGAF states that there is a current, transition, and final architecture. This is a huge help, but it has to be done carefully, because otherwise people will be fighting against it, and we don't want it, definitely.
So does it demand a lot of some kind of talking to people or making them aware how to work with people to make this canonical model work?
Yes, so canonical model should be defined using business knowledge on the domain we are processing, and it's very hard to define upfront. Usually we are doing a few projects before we introduce the canonical data model, because we need to firstly understand what are the producers and what are the consumers, and if we need to do some additional mappings, maybe we need to create some adapters that are changing data from one system to another. So there is a lot of business discussions. We need to define master data, reference data, we need to define transactional data and others, and then we can just implement some, let's say, module that takes care of these checks, right? So we have additional block that is supporting all of these checks. But everything on this side starts on the business, and we need to have a very, very good business understanding of what may come actually from the data producers. So we need to again discuss with data producers on what do they do, how do they do it. And unfortunately, there is one issue: very often hit the wall on the producers, because they are owners of the data and they will not change their own model to match ours. So we need to very often discuss with them that this is a best practice on this domain, or for example on retail or in finance, that this field is defined like that. And unfortunately, you need to revert your 5 years of work to match this, for example. And these are very hard discussions that are ongoing for decades sometimes. But in the end, if we have canonical data model on the whole end-to-end process, this is extremely efficient, really extremely efficient. It's hard to get, but it's again iterative process. We are working on the agile world, and we want to keep things both backwards compatible, but also we need to make sure that we are driving toward some standardization that will just simply help.
Okay, so when we are talking about standardization, I know that there's something like data contract or data contracts. Could you tell us a little bit more about this concept?
Yes, data contracts are having quite a lot of tension last years, and this is actually a very helpful concept. If we are treating our data set or set of data sets as as a data product, this can be shared using some principles, or can have standardized sharing concepts, standardized information about what are the SLIs, and who is the owner of that, what is the version, how often it is refreshed, for example. All of this can be placed into a concept of data contract, where we have usually it is some YAML file, so standard people can understand this. Usually YAML is better than JSON because JSONs are also wrapped. So usually we are defining some YAMLs where in English we are describing what does the dataset do, how to get access to this one, what are the SLAs, and these are of course usually again automated from other systems. So for example, let's say from my experience, Colibra is a good system to define these values and just get into data contracts, and these data contracts are then shown in data catalogs. Also, person that is looking for data, they can check what is the data about through this standardized contract. So each product receives its own but standardized template on what is it, how to get it, what are the characteristics of this. There is a good concept of the open data contract. There is a repository that I think I'm not sure, but I think PayPal is defining mostly. There is a standard concept of these contracts, and this concept is this like canonical data contract model, let's say, where such data contract could be standardized across all industries. And this is potentially what we would like to do on standard data models, on how do we search for data, maybe not the applications itself, but how we behave actually. So it also supports the standardization of how we treat the data. So if we have proper data contracts, we know what we are looking for, we can trust it basically. So this is very useful concept, and I highly encourage to at least take a look at it. Maybe the data contract may be a lot, because it is usually for large companies, I would say, same as things like data mesh, or maybe not the data warehouses, but there are some large companies concepts only. But for data contracts, we really can take a look how it looks like, and we can even develop something similar. It can be even Excel for some smaller companies, but we need to be able to somehow ensure that data is trusted. This is very important.
Sounds good, yeah. If every company has such standards, the life of data engineers would be easier.
Yeah, definitely.
And of course, the life of people working there, because they could use this data if it was standardized somehow. Well, and so what? So when it comes to smaller companies, you just recommend just working at least at Excel spreadsheets to create similar thing, or maybe there is something else, because I think that now in this age of data and
Mhm.
data like treated like an oil, yet I think that a lot of smaller companies are thinking about using data, so probably they should try, yeah, to do it correctly at the very beginning, because if you don't do it at the very beginning, then it's quite difficult, yeah, to implement it in the future.
Yes, but the point is that data contracts again require a lot of upfront work and a lot of additional automation, connectivity to another systems that are again they need to have separate teams that are working on this. So the way we would start is simply to create set of rules or like recommendations and then distribute it down basically. So we want to recommend some approaches. If you want to do it differently, well, I guess that's fine. Maybe for some companies this is mandatory, for some companies this is just a recommendation, but we should have set of recommendations that people will just implement, and they may not 100% adhere to these rules, but they are slightly there. It will be easier to migrate in the future, because we also should remember that if we are small company, let's say, or let's say medium company, and we aim to be a large global company, we should never create systems that are prepared for global company scale, because it will take so many resources. It will be just completely inefficient. We need to do, again, as TOGAF states, as TOGAF standard, the open group architecture. We need to have a current architecture, transition one, and final or to be architecture. And this transition architecture may not have all these concepts, even none of them potentially. And to be can be in like, I don't know, 5-10 years maybe. Of course, we should basically reiterate architecture every year, every 2 years, but we should do things fit for purpose at the beginning, and then we can slightly standardize, we can generalize. So we need to make sure that things are not over complicated, because we will not operate on this. It will just break basically. We need to make sure that we have right resources using right architectures.
So do you mean small steps?
Yes, exactly. Small steps, and of course, it's never optimal. It's not possible to have things optimal. It's definitely not possible. But we need to make sure that using these small steps, we can go into larger sizes, more revenue, more operations, more customers.
Yes. So as usual, yeah, just small steps, and don't expect that it will be perfect. Just iterate.
Yeah. Yeah, we are not talking about unicorns, right? We are talking about business that operates very well. This is much more than most of the businesses that are like standing up right now. So this is important to have high expectations, but also to be somewhere on the ground. So we are not aiming into 1000% revenue growth, right? By using some Excel spreadsheet, but we are talking about happier people, let's say, because we can define and support them with this, for example, with contracts, or even simple rules that, for example, for each data set we should have some set of data tests, because they will be able to sleep well in the night.
All right. You said actually that we can make people more happy, and we can support them somehow. Here comes, this idea AI. So, well, what about AI and data integration? What do we have here?
I was thinking about this some time ago, because AI is currently going into every field, in data, in other fields. It's everywhere, right? And generative AI can support a lot more on the data set, because the rules on the data should be static, but the data itself is never static. It's always dynamic. Many things can go wrong. The number of possible values in single fields is like exceeding the number of items in universe, right? So it's very hard to even define, and that's why the concepts of Gen AI, or this more dynamic math, can definitely support the data integration. And I think the coolest part potentially would be to be able to simply monitor any anomalies in the data. So for example, we are not integrating data that has anomalies, for example, and these anomalies can be, of course, they can be defined statically, but also they can be defined in more dynamic way through using some transformers or other neural networks. And this is, I think, good enough actually, because it will support a lot. It will avoid a lot of issues that may be hard to curate actually. But also we can, additionally to that one, we could try to do data mappings in a more dynamic way. Let's say we have standard mapping from system A to system B, and some fields cannot be matched. For example, there is new field that is coming from the producer, and they haven't informed us about this, which is a big blunder, of course. But we don't want to fail the integration due to that. And some integration may fail, some integration can be prepared so this field is simply dropped, for example. But if we would like to then, we need to then reload this. So we drop this, and they inform us further, and we need to reload this, or or like again trigger this whole process, and it costs a lot. So for example, GenAI could help us with doing it dynamically. So there is a new field, or for example, field has changed name, or maybe they changed the name but the information inside is exactly the same. GenAI can fix it in the fly. So this can be like bulletproofing the integration, and I think this may be kind of cool especially in low code or no code platforms where we may have these modules or like the flag that switch on AI or something like that, and this will again, it may be slightly dangerous to the data because it may do something unexpected. It has to be properly tested, but on the other side, it can help us with these unexpected behaviors.
So these
And
these two, or do you have
yeah, and
another?
there's one more I would really like to see in 10 years, let's say, is this end-to-end self-curation of the data integration. So for example, if there is some new data that is coming, and let's say the data is, I know, from one of the producers, we've got zero inventory where we should have like 1 million, for example. And in the best world, we would get as much data as possible in the system, and everything that is depending on this data, on this invalid, the data would pass, right? But it's invalid data, it's not correct information. We could find out that this information is incorrect. We could circle back to the producer and, for example, do some action like notify them, or we could, for example, get this data again because maybe there was some issue, and this data would come again to us. So in like full automation on the end-to-end process. And again, this would be potentially uh, a bit dangerous. It had to be tested, but if we have this process as well as established, we have this process, for example, documented, so the AI routing of these requests could be automated, that could be really great, because then data engineers would have just time to do other things rather than fixing manually this data. And so this like end-to-end self-creation to the systems, and I think that there is a field, AI ops, that is also doing that on the infrastructure level, is already happening, but it's a long way to go, definitely a long way to go.
And when it comes to this data end-to-end, curation that you've mentioned, and hopefully we'll have it in 10 years, it would definitely also make data better, and maybe we'll have more data thanks to that. Am I thinking in a right direction, or am I wrong?
I would even say that we will have less data, but it will have a good enough quality to be right amount of data. Because very often we end up with large data sets and most of them is not used, for example, or some of it is incorrect, and we get this information like after a month or 2 months of processing of it. For example, we train a AI model based on some data, and we then analyze what does the model do in production, and after a week or two in production, we see that, for example, some product is very inefficient, or some very subset on the prediction is inefficient, or is not getting on properly. So this could be again found out automatically or overall avoided, because we could get information which producer produced this training data. So we could have this as a data catalogs usually have this lineage. The AI could even point out which, based on this lineage, it could point out where is the issue, and it could curate it or ask for curation. So this could be more automated, so we wouldn't need so much like discussions. Like we have clear information that this system, it did something improper, and we need to ask them or again trigger something on their side, so it can be corrected. So these are small things, but there are so many of such issues that we are spending most of our days on this. So if we could get systems like this that supports data engineers on finding and curating issues, this would be a complete game changer, if it would be productionalized, of course, because we can have some proof of concepts for that, or we can have some like small deployments. But if it would go to the large scale, then it would change really the data quality on every level.
That sounds really, really great. Because then, as you've mentioned, probably the life of data specialists would be easier. And here we come to our last question today. Well, what's the future of data engineers and actually data integration?
I think data integration overall will be needed all the time. up to the point where we can define whole integration fully automatically using the just business requirements that are translated somehow slightly better, because business requirements do not think about data integration. So I think the data integration will be needed, and it will be much more needed, especially because we are now moving into these multi-agent structures. We are moving more into Gen AI. Gen AI usually operates on vector stores, so we need to again define processes to integrate these vector stores with each other. They are having different models within, so they have different dimensions. We need to standardize them. It's a very large subject, and I think the data integration will be more and more needed on more and more fields as of now. And potentially there will be some automation. I hope there will be much more of it. But as of now, we will just need to have more data integration specialists, and potentially we need to have business that has much higher data literacy than the current one. Let's say it is an issue that we are not talking the same language. This is the same otherwise. The technical people should be more knowledgeable about the business, and business about the technical part. So that's why I also always advocate about this generalized kind of person, where we can do we can talk about everything at the same language, we can discuss everything, but everyone has its own some kind of larger specialization, but we are aligned on the fundamental level. So this is very important, and I think this will be also the case in data integration, where data integration people or overall engineers will need to more understand the real world and the business.
So probably then this one source of data will work for that, yeah? Because if you will have access to it, maybe you will understand it better. Or yeah, it's my idea, that if you have the knowledge, some place where you have the knowledge about your company, you can actually ask some question, yes, through some chat, and get to know something. So if you are not aware about the data, how you should work with that, you can ask about it, and actually you see the value in that if you have really fast access. So probably it will work both ways. If some data engineer doesn't know something about business, they can also ask him.
Yeah, I think so. This like large knowledge bases will be more and more important in the companies, because business could ask, let's say, at what time the data was processed today, and they don't need to ask us. They can just see it somewhere, right? So this is not only monitoring, but also this up-to-date knowledge bases where they can see what is actually there. Like, for example, for data engineers, they can see what is the actual data architecture, not the one that they think it is, right? For business, they can see what is the data characteristic on some data set without actually asking us or like creating tickets for this one. It just improves a lot of in the communication and speeds up the business, of course. And there is a nice way of talk to your data. It's like you can ask a question in English, and it will just find right the data. It will create an SQL query for this one, and it will return results, and it will answer you again in English. So this is like very nice way of placing the not only business but overall people, including technical people, on validating what is the data like right now, or what is the state of the data. What do we have? We can query this, but we can also just ask, right? We can simply ask. So this is also a nice way of smoothing the whole data integration and overall data world.
What you've mentioned is also that we should be close, yeah, to each other. I've heard about the idea, about the concept that actually now we probably are going to just not like one team of data scientists or data engineers, but people working also closer to the business, yeah, to these people, just to communicate better. Do you believe that this is a great way of doing that, or maybe it's just better to work separately, or it depends?
Actually, there are two concepts on that. The first one was DevOps in 2009. They already mentioned that cross-functional teams are the most efficient. It was in 2016. Was a really good book on research on this DevOps, but I don't remember the name right now. But I think we can paste it later
Of
on.
course.
So the DevOps was first approach on getting these teams cross-functional, so the people on different levels, on different specialties, are working on day to day. They know each other, they have some integrations, go out together, they can work together. And second part is data mesh, where data mesh supports this data ownership and domain alignment. So that the domain, the set of experts, not only on business but also on technical side, they know the business and they know the technical part, all of them, or like most of them, right? Because there are of course different levels of needs. But these two concepts are more and more important, I think. And again, this triggers these needs for data literacy, for education, and for generalist approach.
So last thing, because actually you've of course answered to the future of data integration, but what about the future of data engineers?
Data engineers will be always needed. That's the most important information. The data is so dynamic and it's so by itself so unreliable. We will always need to have people that are specialized in data world. And this is on distributed systems, this is on databases, this is on the data integration. Overall, the data engineer, even now, they simply need to be able to handle any type of data at any time, including the data architectures, including the types of how we process, how we store the data, how we secure the data. So this is again like very, very wide space, and data engineers will just need to, they will be needed definitely, and more of them will be needed. Potentially there would be more of a concept like software engineer with data, or in data specialty, it's like now data scientist with Gen AI. This is just generalist person that knows very well this whole data domain.
Oh, thank you, Filip, for such a great talking today. Well, and that's a wrap for today's episode of Data, Big Challenges, and Real Success. Huge thanks to all of you for listening. We truly appreciate you spending your time with us. And of course, a special thank you to Filip Dzięcioł. Thank you, Filip. It was really nice to meet you here.
Thanks a lot, and thank you all for listening.
Well, super valuable stuff, really. It was really, really good. Thank for accompanying us, and I hope that it's not our last talking, and in the future we are going to meet again to talk a little bit more about data and how it has changed, because it's such a very intense and very fast world that I think that next time we are going to talk about another concepts. Probably.
Definitely.
Yeah. And well, if you found this episode useful or inspiring, don't forget to follow the podcast and share it with someone who might enjoy it too. And stay tuned. Of course, you can follow our LinkedIn channel. And till next time, see you.